me glad. Fair is fair.
Welcome to our tutorial on solving equations that need to be simplified first. Now that we have a basic understanding of how to use inverse operations, we are going to introduce equations that become more and more complex. As we develop our understanding of solving equations, understand that the basic principles will always stay the same, so we can apply them no matter how complex the equations get. First, we're going to learn a basic strategy that we can apply to solving any linear equation. Then we're going to focus on solving equations after we simplify the expressions on both sides. I like to break down the process of solving equations into 4 steps. First, simplify both sides of the equation. Second, get all the variables on one side of the equation. Third, undo any addition or subtraction that's on the same side as your variable. And finally, undo the multiplication or division. Often students look at a complex equation and have trouble knowing where to begin. But having a strategy like this gives you a place to start, no matter how confusing the equation looks. Another important thing to understand is that while this method will always work, don't be afraid to try different variations of it if you see that it might make the problem easier. Again, the beauty of mathematics allows us to solve problems in many different ways. So while this way always works, as you get more comfortable with the concepts involved, you'll discover that sometimes there are more efficient strategies to use. Let's begin practicing our general strategy by solving the equation 3x plus 3 minus x equals 2 times 5 minus 1. Please note that blue objects represent positive values, while red objects represent negative values. Also, we are going to wait until the next lesson to work with equations that have variables on both sides, so for now, we don't need to worry about the second step. It's already done for us. First, let's simplify both sides of the equation. On the left side, we see that there are 2 terms that have x's, 3x and negative x. Since these terms are alike, we can combine them to get just 2x. This leaves us with 2x plus 3 on the left side of the equation. There are no variables on the right side, so we can simplify by using the proper order of operations. If we multiply 2 by 5 to get 10, then subtract 1, we end up with 9 on the left side of the equation. Now we can move to our third step, undoing the addition or subtraction. In this case, on the side the x is on, we have a plus 3. So we need to subtract 3 from both sides of the equation. Once we do this, we're left with 2x equals 6. Finally, our fourth step is to undo any multiplication or division. Here, x is multiplied by 2. So we need to divide by 2. This gives us our final answer, x equals 3. For our final example, let's solve the equation 4 times the quantity x plus 5 minus 14 equals 1 minus 6 squared. Due to the complexity and larger numbers involved in this equation, we won't use the shapes to model this one. Let's work through our steps now. First, to simplify the left side of the equation, we need to distribute the 4 into the parentheses to get 4x plus 20 minus 14. Then we can combine the plus 20 and minus 14 to get 4x plus 6 as our completely simplified left side. To simplify the right side, we need to square the 6 first to get 36, then subtract 1 minus 36 to get negative 35. Now we're done with step 1. All of the x's in this equation are on the left, so we can skip step 2. For step 3, we need to undo the plus 6. So we subtract 6 from both sides of the equation to get 4x equals negative 41. Finally, since there's multiplication on the left side, we need to divide by 4 to get our final answer, x equals negative 10 and 1/4. Now that you've seen a few of these examples, try the activities to practice solving equations for yourself.